Hello everyone, I am Mili Trivedi from LG Institute of Engineering and Technology, and today we will study about torsional vibration 2 and 3 rotor system with the numericals. So let us start our theory. Let us have two rotor A and rotor B, and having the shaft which is having the length of L. Okay. So now for this system we have to consider that if both the rotor rotates in the same direction, then what will happen? There is zero node position because none of the point it will not vibrate at all. Okay, they simply rotate in the simple manner. Hence, the vibration is zero, and so it is known as zero node position. Now let us assume rotor A and rotor B rotates in the opposite direction. If they both rotate in the opposite direction, then what will happen? So in this case, we will get a point which is known as node point at where there is zero frequency. So from that node point, right hand side as well as left hand side both will rotate in the opposite direction, and hence we will get vibration with respect to each other of rotor A as well as rotor B. Okay. So now let us have the length from that nodal point of the rotor A is LA, and the same point from the nodal point to the rotor B is LB. The amplitude of rotor A considered as beta A, and the amplitude of rotor B will be considered as beta B. So now let us compare angular frequency of two rotor. So by comparing this angular frequency, we will get omega NA is equal to omega NB. Now let us have and put the values of under root of kT by Ia is equal to under root of kT by Ib. Let us put the values of kT. So what is kT? It is T by theta, and which is equal to Gj by L. So by putting these values of kT, we will finally get the answer as 1 upon LAIA is equal to 1 upon LBIB. So that we can write LAIA is equal to LBIB. So finally we will get LA by LB is equal to IB by IA. So this is two rotor single node position equation. Students, this equation is very important because we want to solve the total numerical of the system. So if we consider this equation number 1, we can easily find out the values of natural frequency. Okay, so you have to note down it. Now let us start our three rotor system. Let us say our three rotor is rotor A, rotor B and rotor C. First of all, we have to calculate for two node position. So for the two node position, let us assume rotor A and C rotate in the same direction and rotor B will rotate in the opposite direction. So then what will happen? Between A and B we will get one node position, and between B and C we will get another node position. Now as we know, from the rotor A the nodal point position length is LA, and from the rotor C the nodal point position is LC. Okay, and the remaining length is L1 minus LA as well as L2 minus LC. Okay, now let us solve this kind of two node position. So for this case we have to compare all three frequencies. It means omega Na is equal to omega Nb is equal to omega Nc. But simply we cannot compare all three equations, hence we have to compare it in parts. It means first we need to compare omega A with omega C. So let us compare omega Na is equal to omega Nc. So this kind of comparison will give us the effect of two rotor system. So we will get simply by solving this equation, we finally get the answer as LAIA is equal to LCIC. Okay. Now finally we can also write the equation as LA by LC is equal to IC by IA. So this is equation 1 for two node position. But what about rotor B? So for the rotor B we have to consider KT1. It is Gj upon L1 minus LA, and KT2 is Gj upon L2 minus LC. By comparing this equation we will get KTB is equal to KT1 plus KT2. So for this we can find out the value of KTB is Gj upon L1 minus LA plus Gj upon L2 minus LC. So here let us compare the equation of omega A with omega B, so that we will get under root of kt upon Ia is equal to under root of kt upon Ib. Now put the value of kta as well as ktb. By putting these values of kta and ktb, we will finally get the answer as 1 upon LAIA is equal to 1 upon L1 minus LA plus 1 upon L2 minus LC into 1 by IB. So this is for the two node position. Okay. Now let us have single node position. Single node, it means there is only one point in which we will not get any kind of vibration. At that point is E as we see. And the length from rotor C to the point E is LC as we note down in this condition. It means how this system we will get. Suppose rotor A and B rotate in the same direction and rotor C will rotate in the opposite direction. So by this effect we will get the nodal point position at E. Now let us solve the two triangle position. In this case, we have to enlarge the length LO, which will map to the base line known as AC, and let us enlarge that line so that we will get two equivalent triangle name as AED and BOD. These both are two equivalent triangles. Now let us compare both these triangles and we will get beta A by Ia is equal to beta B upon Ia minus L1. Okay, so this is our standard equation. Now let us have torsional equivalent shaft. So in this torsional equivalent shaft, we have rotor A and rotor B, different diameters. So we are having the stepped shaft. It means diameter D1, D2 and D3 and the length L1, L2 as well as L3 in our case. If we want to solve this equation or the theory, first of all we have to consider that both these rotors rotate in the opposite direction. It means shaft rotate and will turn at angle theta 1, second portion will turn at theta 2 and third turn at theta 3. Hence, if we want to find out the total angle, we need to take a sum of all three angles. Now, first of all, find out the value of theta. So, what is the equation? D by theta is equal to Gj by L. It means theta is equal to TL upon Gj. Now, let us solve this equation. Theta equivalent is equal to theta 1 plus theta 2 plus theta 3. Now, by solving this equation and putting the values, as we all know, torque is similar for all three rotors as well as modulus of rigidity is also similar. Now, in our case, what is polar moment of inertia? It is pi by 32 d raised to 4. Hence, by putting all these values, we will get Le upon d raised to 4 is equal to L1 upon d1 raised to 4 plus L2 upon d2 raised to 4 plus L3 upon d3 raised to 4. Now, by solving this equation, we will get the answer as Le is equal to L1 d by d1 raised to 4 plus L2 d by d2 raised to 4 plus L3 d by d3 raised to 4. Let us assume the equivalent is equal to d1. So by assuming this, we will get the answer as Le is equal to L1 plus L2 d by d2 raised to 4 plus L3 d by d3 raised to 4. So this is the final equation of equivalent shaft. Now let us check the numerical. For the numerical, the data is as two rotor A and B attached to the end of a shaft 1.6 meter long. It means length L is given to us, which is 1.6 meter long. The mass of rotor A is 2500 kg and radius of gyration is 0.8 meter. Corresponding values of rotor B, it means initially the mass and forwarding the radius of gyration. So which is 500 kg and kb is 0.5 meter. Now, diameter of a shaft is 180 mm for the first 0.5 meter, 220 mm for the next 0.4 meter and 100 mm for the remaining length measuring from rotor A. Now, assuming modulus of rigidity is 0.8 into 10 raised to 5 megapascal for the shaft material, find position of node and natural frequency of torsional vibration. Now, as you see, we have to write down the data. What is the total length? It is 1.6 meter. Mass A is 2500 kg. Radius of gyration is 0.8 meter. Mass B is 500 kg and radius of gyration is 0.5 meter. Diameter D1 is 180 mm, D2 is 220 mm and D3 is 100 mm. So that we can write 0.18 meter, 0.22 meter and 0.1 meter respectively. Length L1 is 0.5 meter, length L2 is 0.4 meter and L3 is 0.7 meter. Modulus of rigidity is 0.8 into 10 raised to 5 megapascal. Hence we have to write 0.8 into 10 raised to 11 Newton per meter square. Now, this is our system. Rotor A, rotor B, L1, L2, L3 different length, D1, D2, D3 different diameters. For solving this, we have to calculate the mass moment of inertia and which is IA, which is MA square. So by solving this equation, we will get 1600 kg meter square. Mass moment of inertia of IB, it is MD kb square. So finally, we will get 125 kg meter square. Now let us solve the equivalent length. And what is the equation? It is L equivalent is equal to L1 plus L2 d by d2 raised to 4 plus L3 d by d3 raised to 4. By solving this equation, we will get the final equivalent length as 8.01 meter. Now let us have the equation of LAIA is equal to LBIB. So by this, we will get the relation of LA and LB. So LA is equal to 0.078 LB. Okay. Now let us put the value of LA in our equation. So LA is equal to LA plus LB. So finally, we will get LB as 7.42 meter and LA is equal to 0.57 meter. Now, what is polar moment of inertia? So, it is J is equal to pi by 32 d1 raised to 4. By putting the value of d1, we will get the polar moment of inertia. Now, let us have natural angular velocity. So, what is natural angular velocity? It is omega n under root of Gj by La Ia. So, by putting all these values of G, polar moment of inertia J, La and Ia, we will get angular velocity as 95.08 radian per second. Now let us find out natural frequency of a system. So what is the natural frequency? It is omega n by 2 pi. So that we will get 15.30 Hertz. So this is natural frequency. Now students, if you have any query, you can ask me. This is our torsional 2 and 3 rotor system including the numerical. This theory is really very important according to exam point of view. So you have to check it. Thank you.